everyone. All right, so I'm going to go over a quick intro to subnetting, and we're going to start with the subnet bar chart because I like this to help you visualize how to break up the different networks. So when we are working with our networks, mostly I've talked about /24s in this class, and that's all we've dealt with, which when we do a /24, it means that the first three octets are the same number, and then only the last octet is the one that changes, right? So an IP address 192.168.1. something 0 through 255 is a typical address that you're used to seeing. So that 0 through 255 portion is what we're looking at in this bar chart right here on the screen. So we can break that up because if we do the 192.168.1.0 through 255, that first three, the 192.168.1, that stays the same regardless. And what that means is that we have 256 total addresses to work with. Well, what if we needed to break that down? What if we needed less addresses? Well, that's where we go to a different CIDR, where we can move up to a 25, a 26, 27, 28. As we move up in CIDR, we get less addresses per network, but we're able to get more networks. So if we take a look at this, you can see that in a /24, we have this one single network, okay, and has a total of 256 IP addresses. If we go to a /25, all we're doing is we're splitting that in half. Pretend it's like a candy bar, and you break it in half. And now you have two pieces of candy bar, right? And so, but within those pieces of candy bar, say it's a Snickers, we have the whole candy bar has 256 peanuts in it. If we break it in half, each half has an equal number of peanuts. So the first one half has 128 peanuts, and the other half has 128 peanuts, right? And then if we break those halves in half, okay, we break each half of the candy bar in half, then we are once again splitting the number of peanuts per section. So now we have 4 pieces of candy bar that we can dole out, but we only have 64 peanuts per candy bar, or in this case, IP addresses. And it just keeps going that way. Split it in half again, right? So the number of pieces of candy bar we have increases to 8 if we split all our halves in half, and the number of peanuts that we have per section decreases. So now it's 32. So it's all halving and doubling. And the reason for this is because it's all base 2 math. It's based on binary, ones and zeros. So we're going to take a look at that. I've already done in a couple of videos, I've done, converting from binary to decimal, decimal to binary. So you should have an idea of how that's done. And then I also did in the last lecture towards the end, I did another review of subnetting. So now we'll get into it. So this is the visualization of it. And you can see that if I have 192.168.1.0 network, okay, so the network ID is the first address, always. It's not usable. You can't assign it to a host. It just identifies the network. And I said it was a /25, then I would be working with this section right here, okay? If I had a 192.168.1.192/26, I would be working with this section here. Okay, so the 192 identifies the network, and then the /26 tells me that this is my network ID and these are the usable addresses. Okay, so I would have 193 through 255 as my usable address, or 254. 255 ends up being the broadcast. So the very last address is the broadcast address. The very first address is the network ID. So what I have written on here are the network IDs and the broadcast addresses. And then anything in between is our usable addresses that we can assign to hosts. Okay, so let's switch over to All right, so this is what I was just talking about. We're just going to work with /24 right now for this moment. We will move up and start looking at working with /23, 22, 20, and I know we're going to do that because it's on your final. So you're practical. You have to do this for your practical. So get good at subnetting because that's the first part, and if you can't do that part, you can't do the rest of it. All right, so we're going to start with this 3 sections, and really all of you should have taken IT 111, so you should have gotten some subnetting. So this should be bringing up old memories and awakening you, and you say, oh yes, I remember doing this. Okay, so essentially the format that we have, the X's would represent a number, right? So it could be 192, 168, 1, and then I put the .0 there as like a network ID. And what that looks like, what the subnet mask looks like, because the mask is what tells us everything. And this /24, this is the mask. It's the mask in binary. It tells me how many ones I have describing my network. So everywhere there's a 1, that part is part of the network ID. So I have 8, 8, 8. I have 24 ones on here. That's where the /24 comes from. And then to make up the total of the 32-bit IP address, the last octet is all zeros. I have to have 32 bits total, but it's all zeros because it's host portion. And I can show you the base 2 math that tells me, based on the bar chart that we looked at in a /24, we have one network with 256 addresses. So we have exactly 0 ones in the last octet. Okay, there are no ones in here. So what I have is 0 to the power of 2 because it's base 2. And I take that back. I did that backwards because I'm recording this in the morning and I'm not a morning person. Okay, we have base 2, base 2, 2 to the power of how many ones I have in that last octet, which is 0. So I have 2 to the power of 0. And when we are doing exponents, anything to the power of 0 equals 1. I once had a student tell me chicken to the power of 0 is 1. Because that's what a math teacher told them. And math teachers know what they're talking about, so we're going to go with it. So chicken to the power of 0 is 1. 2 to the power of 0 is 1. A million to the power of 0 is 1. And there's really interesting proofs out on the internet. If you want to look up the proof that shows anything to the power of 0 is 1, I highly recommend you do it. It's very good. I'm not good at reproducing it, but it is very interesting. And it demonstrates that no matter what you do, anything to the power of 0 equals 1. So what we end up with is one network. Okay. Now, for the rest of it, let's address the IP addresses. That's how many zeros we have. Well, there's 8 of them there. So I have 8. I did it again. I'm not ordering my thoughts very well. I'm still on base 2 math. I have 2 to the power of how many zeros I have, which is 8. And that's going to equal 256 IP addresses. You can get a calculator and you can do it. It's actually pretty easy to do in your head. It's not big math. It's just 2 times 2 times 2 times 2, 8 times. So you'd write out 8 2's and multiply each of them. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, times the very last 2 is 256. Get used to doubling those numbers. You're going to want to memorize that, right? So when we double 2's, 1, 2, 4, not 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, 8,100 and something. I get lost after that for the exact number. So we keep doubling, and that's what's going to happen when we start moving into this octet. Is what we're going to get is we're going to get more IPs per network. So say I need a really big network where I have 1024 IP addresses, what's going to end up happening is this is going to be a 0 and that's going to be a 0. And then I'm going to have all of this as network and the rest of this is host. So what I'm going to end up with is 2 to the 10th power, which will give me 1024 IP addresses. All right, so as we move up, we get more addresses. Okay, so now whenever you're doing subnetting, my recommendation is to write out the mask, not the IP address. The IP address doesn't matter for right now. The only reason you would ever need to write out the IP address in binary is if you're trying to figure out what the network address is for a particular network. Okay, then you write out the IP address in binary and you match it with the subnet mask in binary, and then the resulting ANDing, you AND them together, and I'll talk about the Boolean values for the ANDing. Once you AND them together, that tells you what your network ID is. So that is on the CCNA test. If you're interested in taking that, they do expect you to know how to do that. So, but I'm not going to go over that right this second. Let's get to some more subnetting. So what I want you to do whenever you're subnetting is I want you to write out the mask in binary, and then doing the base 2 math is really the easiest way to do it. Or you can use the subnet bar chart and you can take a look at that. Or I have another chart that I write out. So let me write that chart. Oops, let's use this. Okay. D6, one network. Okay, so what we're going to have here is these are going to be the IPs. This is going to be your network. This is going to be your mask. And this is going to be your CIDR notation. Sorry about my chicken scratches. It's kind of it's not really a tablet, so it's kind of awkward to write on. All right, so we have 2 networks, we have 4 networks, and notice the doubling is opposite. We have 8 networks, we have 16, we have 32, 64, 128, 256. And the last 2 we don't really use when we go up this high, but we use them when we're in the other octets. Okay, so our mask is going to be 128, 192, 224, 240, 248. Uh-oh, I didn't leave myself enough room. 252, 254, and 255. And this is going to be a /25, and a /26, and a /27, /28, /29, /30, /31, /32. And we do use /32. You'll see it on the routers if you look in the routing tables. It always shows you what network the router knows about, and then what the /32 IP address that is assigned to the interface associated with that network. So we do see the /32s. We just, in general subnetting, we're not going to really make that. The other time we use that is when we're writing things like ACLs, and we need to identify a particular IP address. We're singling out an IP address for, whether or not we're filtering traffic into it or out of it. So that's another reason we'd use a single IP address and use that /32 mask. Okay, so using the subnet bar chart, or sorry, using the this subnet chart, we can look at this and I can say, if you have a /27, I give you an address that's a /27. Let's say it's 10.10.20.0 and it's /27. Okay, then we're looking at that. You can look at that and you can say, well, in this, for this /27, I have 32 addresses in here. So I have 0 through 31. Okay, so 0 is my network ID, 31 is my broadcast ID. So my usable addresses, so if I say -2 for those items, I have 1 through 30 as my usable addresses. Okay, for this particular network. So this just describes this network. And I could do the same thing. I could say if it was 10.20.128, then I would say, okay, well, I have 128 through 159 is my range, and then my usable addresses in there are 129 through 158. The other thing I want you to really recognize on here is just kind of a quick check to keep you on track, is that network addresses, network IDs, always start with they're always an even number. They're always an even number. So I can't have a network ID that is .129. That will never happen. And then the broadcast ID is always odd. So my broadcast will never be .160. You miscounted if you end up with a broadcast ID that's an even number. So that's a really good way to check yourself. Okay. So we can do a quick subnetting here. I'm going to erase this for now. Okay. Let's see here. All right. So let's say that I have 192.168.30. We'll just start with .0. And so I have this address, and I want what I need. Okay, I need at least 6 networks. Okay, and that's my only requirement. I need at least 6 networks. Where do I go on this chart for at least 6 networks? Well, if I look at the network range, 6 isn't an option. I can have 4 and I can have 8. Well, 4 is too little, so that doesn't work. We don't want that. So so we have to go with 8. Okay, so I'm going to be in a /27 at that point. Okay, so we're going back to our /27. Let's take a look at this. So the first thing you should do is always write your mask in binary. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That gives me 16. 1, 2, 3, 4, 5, 6, 7, 8. Is 24, 25, 26, 27. And then 1, 2, 3, 4, 5 for a total of 32 bits, right? So we decided that this is going to be a /27, okay, based on the chart. Now, if we didn't know it was going to be a /27, we could work this out. So if we just look at this and we say, okay, well, if I do my base 2 math on my networks, 2 to the 3rd power, be a 3, is 8. Okay, so we know we're good on 8 networks. But let's say we didn't have this pre-knowledge. We're not going to go about it this way. There's a different way we could figure this out. So we could say, well, I'm going to start with this /24. This is what I was given. All right, so let's just assume we started with a /24. They said, here's your address, or here's your network range that you have to work with. And within my area, I know I need to separate this into 8 networks, or 6 networks at this point. I'm going to have 2 left over is what's going to happen. But I've been given this address range, and I need to split it into 6 different networks at the very least. So if I'm starting with a /24, 1, 2, 3, 4, 5, 6, 7, 8, how do I make this change? Well, I go to a /24 and I say, well, what if I convert one of these to a host bit? What do I end up with? Well, that's 2 to the 1. That gives me 2 networks. Well, that's at a slash 25, that's not going to work. That's not enough. That's only 2 networks. If I convert this bit, I'm now at 2 to the power of 2, which is 4 networks. Well, that's not enough either, so I need to convert one more. That now gives me 2 to the power of 3 networks, and that's 8 total networks. So that's the winner, okay? And that's how I end up with a 27. So I still have 8, 8, 8 for 24, 25, 26, 27. So that's where I get the slash 27 number. And what this has told me is I now have 2 to the power of 3, which is 8 networks, and I have 2 to the power of 5, which gives me 32 IP addresses per network. And now I can split this up. So I'm going to scroll up above the chart. And what I'm going to end up with is 192.168.30.0. My first address is not gone just because it initially identified a slash 24. It's just like the candy bar. You know, when you break the candy bar in half and you split up the number of peanuts you haven't eaten any peanuts at this point. You're just breaking the candy bar up. You're not actually eating anything. And so the addresses don't go away. They just get repurposed, reorganized, right? Another example I like to use is M&Ms. You have a pile of M&Ms. There's 256 of them there. If you split it into 2 equal piles, you have a pile that has 128 and another pile that has 128. You still have 256 M&Ms. You haven't eaten anything. And all those M&Ms are labeled from 0 to 255. Now, be real careful because 0 to 255 is a total of 256 because 0 counts as something, right? So that's where students usually get wrong in their counting is they forget that 0 is an item. 0 is tangible. So make sure that you don't forget that. So I end up with 192.168.30.0 slash my new CIDR, which is 27. My second network is going to be 192.168.30.32 slash 27. And then this is just going to keep repeating, okay? So it's going to be 32 and then 64 and then dot 96 and then 128. And then we're going to have dot 160 and dot 192. I'm cheating. I'm looking at the bar chart because I got to do the math quickly. 224, and that's it. Okay, and that's 8 total networks, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay, and all of these are a slash 27 because we changed them all. They're no longer, whoops, I was just thinking in my head. They're no longer slash 24s, and if I say it, I'll write it. Slash 27, slash 27, slash 27, slash 27, slash 27. Okay? And all have the same 3 first numbers because these don't change. Okay? Those are all ones. It's matching everything. So these numbers always stay the same. The only thing that changes is what's in the last octet. All right? So now I've split it into 8 networks. And each network has a total of 32 addresses in it. And if you do the math, you can see that. You can see it just from the beginning. So 0 to 31 is my range. And this one's going to be 32 to 63. Right? Remember, the last address is the broadcast address, and it's always odd, which it is. I'm doing this right because this last number is always odd. Okay. So that is your intro to subnetting, and I will do some more videos, but that is the beginning for now. So you should practice that. I put lots of resources on our module for this week for you to go through and practice your subnetting, and so you should do that, and you should start working on my subnetting practice assignment, and we'll talk more about it on Monday.